Okay. Good morning. Welcome back. Nanu. So, give me a question. I know someone's got a question. Yeah.
How was your weekend?
Oh, thanks. I'll pay you for asking that later. It was all right. It was a good weekend. It was pretty busy. I'm kind of redoing some assignments in the compilers course 515 and spent all day yesterday coding. So yeah, I know. That's right. Anything else? Anything about C++ or Linux or Vim or yeah?
For a Boolean function, how do I get it to return true within like a separate if statement? So say I have a Boolean function and I want it to return true to int main. Like I say, like it's up here, like if this happens, it returns true. If this, it returns not. It returns false. So that's the output of that one. And then within int main, I say if this one returns true, then.
Meaning if the so your question is how do you call a Boolean function from main?
I have it all written out correctly. It's just within int main itself, how would I say like if this one's true? The function itself.
All right, so let me see. All right, so first a question. Under what conditions am I returning true and under what conditions am I returning false? Based on the number I type in. So what is, I guess the question is that this isn't something we see frequently until we get into this class, unless you've had previous programming experience, and that is there are two operators on line 10. The second one, I think we've got our heads around pretty well. That is a comparison for equality. So we're asking if the thing on the left is equal to 0. And then that operator, the percent symbol, is representing modulo arithmetic, meaning that it does integer division and the result is the remainder of that division. So if I divide any number by 2, what are the possible remainders? 0 and 1, right? So if it's an even number, it'll be the remainder is 0, and if it's an odd number, the remainder will be 1. A nice little trick to determine whether a number is even or odd. So in that case, I return true for even numbers. Number is even. And I return false if it's odd. Now, let me step up your game a little bit. A better way of writing lines 10 through 13 is this. I don't really need the parentheses, they're a little gratuitous. So let me comment that out. Because think about it, on line 10, the result of that expression is going to be either true or false. So why go through all the extra rigmarole, and why not just return whether or not answer divided by 2, answer mod 2 is equal to 0. Right? So that'd be the better way of doing that. Although I will concede there's a large population of programmers who would do lines 10 through 13, if for nothing else for readability. But 15 is very, very common. So the question was then, how would I utilize that? I can go through a similar discussion as I can say if, actually let's change the name of this function. Let's call this I am happy, and that's true or false. So if I am happy, so my first question is, did I answer your question?
Yeah.
All right. Second, I would step this up here on line 20. Let me actually, hang on. There we go. I would step up line 20 by saying, similar to lines 10 through 14, where there's a little bit of unnecessary redundancy, there's unnecessary redundancy on 20. Because when I invoke or call, I guess I'd say when I call the I am happy function, it is going to give me true or false. I don't have to say if what it gave me was true, because it's going to give me true or false. I can just get rid of that altogether and say if I'm happy. Let's space it out for readability. Yeah.
Could you also put like 0 or 1 instead of 2?
Yes. So in the language, 0 is false. Anything else at all is true. 0 and 1 you do find relatively frequently, and the reason is that the C language, from when C++ was born, doesn't have true or false. The words true and false, as shown on lines 11 and 13, are specific to C++. So in the C language, you would commonly refer to false as 0 and true as 1. So yeah, it'd be equally valid to do that. Any other questions on that? Or on anything else for that matter? Yeah.
So I know that you didn't, like, you told us before to like declare the variable, or like not the variable function, like early in the article. You can just like declare it all in one. If that makes sense. If I worded it correctly.
All right. So you're referring to the I am happy function?
Yeah.
All right. So let me go ahead and do this. I haven't tried running this yet. I suppose as common courtesy I should. All right. So given that I typed that, can you repeat your question?
Oh no, I was just wondering if you could like skip that first step in not declaring this.
As in line 5 or as in line 6?
In line 5.
Yes, that you're correct. So the general principle is when the compiler is crunching on your program and converting it into machine readable form, it's just a stupid thing that goes from top to bottom. And the general rule is before you are allowed to use it, you have to tell the compiler what it is. And there are two ways of doing that. One is I could actually define the function, which is what we have from lines 6 through 17. And that is definitely sufficient to tell the compiler what that function is prior to using it. And of course, I'm using it on line 21 in the main function. Or if for whatever reason I do not have that definition before main, then it is sufficient to tell the compiler what the function is through a function declaration as shown on line 5. Then we're at liberty to move the I am happy function definition anywhere we want, including in a different file, which maybe if we have time we'll actually look at today. So if the function definition appears before its use, then line 5 is entirely gratuitous and unnecessary. But if we do not have that definition before we use it, then we have to declare it. The reason is to provide enough information to the compiler so that it doesn't freak out on line 9. And we can do some illustrating of this. I guess what I ought to do first is, let me go ahead and alright, so if I come here, compile this, I got a bug. Let's see, this is line 12. That second number, by the way, is column 31. So if I go to line 12 and I go to the 31st column, there's the 31st, so that's what it wanted there. Normally the column isn't important, it's sufficient just to have the line number. Oops. Let's try compiling that again, run it, 32, 13. So what happens if I do not have the function prototype and I have not told the compiler what I am happy is before I use it? Make sure I write it. Now when I try compiling it, it gives me an error saying use of undeclared identifier. So that whenever you get undeclared identifier, that quite simply means you're trying to use something before you told the compiler what it is. Another example of that would be if I do something like a equals 32, or I guess with my typo, 321, and it says that it doesn't know what a is. Right? And so that's what something like that is we're declaring what a is. And that works fine. I guess I can comment that out. No need for that. What day of finals week is our final? I don't know. Almost certainly it's going to be Monday. I like how you're planning ahead. But yeah, the 111 final for this section is almost always on a Monday. I think I answered that. That's just division, doing integer division, where the result is the remainder. So we got that one covered. Really? I think I might be able to retire early. All right. I'll look that up. Because up till now I've been paying someone else to drink coffee every time I get a cup. Okay, I don't know. That takes us to this. I can look at the AO8 thing in just a minute. Any other questions about anything at all? Anything in Vim? If you're doing something in Vim and it takes you more than if you're doing something in Vim and it takes you more than about 3 keystrokes, then there's a better way of doing it. Is there anything that you're doing in Vim that's taking you 4 keystrokes? Getting to the end of the line, getting to the 5th word, jumping to the bottom of the file. All right. What's the difference between this top hat tool doesn't let me select that text. That's a joke. Okay, so let me see. So the question essentially is about unsigned. Let me go ahead and come here. Let me quit out of that. There are a lot of modifiers you can put on the integer variable and the char variable as well. If I say integer x, then that's going to give me numbers somewhere approximately from -2 billion through +2 billion. It may be larger than that. I don't know offhand. If I say unsigned, and unsigned, unsigned is a modifier for integer, so the full specification would be unsigned int like that. And what it does is it just simply is notifying the compiler that there are no negative numbers. So the number of discrete values the variable can hold has not changed, just the range has changed. So basically this would go from approximately 0, well, from exactly, from 0 to approximately 4 billion. Okay, so that's what unsigned is referring to, is it's just shifting those valid sets of values. This nomenclature that was used here is correct in that it is perfectly valid to leave off the word int. There's also char. So char ch is something like -127 to +128, and unsigned char is 0 to 255. And whereas I don't know exactly where this is offhand, I do know exactly where this is because, other than me having it memorized, how much room in the machine does a character take? I heard 8 bits, right? So a byte or 8 bits, and you can actually calculate all the possible values from that. So if we have 1, 2, 3, 4, 6, 7, 8. This is going to be. What if this was our decimal system? What if it's our decimal system? Then this would be 10 raised to the 0 power. And this one would be 10 raised to the first power, right? This is so obvious we don't even think about it. So if I have 2, 3, 10 raised to the 0 is always 1, so 3 times 1 is 3. And then 10 to the 1 is 10. 2 times 10 is 20. So what's 20 plus 3? It's 23, right? So you just do the exact same thing in binary, except we don't have 10 possible digits. We only have 2 possible digits. So we replace the 10s with 2s. 2, 3, 4, 5, 6, 7, and those of course work out to be 128, 64, 32, 16, 8, 4, 2, and 1. And so if you flip all, if all these are 0, obviously the number is 0, but if all these are 1, then you add up 128 plus 64 plus 32, and you end up with 256 values, which is 0 to 255, or this range here. And just to say it, they're also, if you need more than if you need more than about 4 billion discrete values, then you can create a long integer, which gives you even more room. And there's even a long integer. Need even more. But by and large, you know, kind of the bread and butter of programming is int and char and float, string, but you do see the unsigned a fair amount depending on the situation. So the net effect, depending on whether I have unsigned here or a regular integer, is none, because 0 through 5 is well within the range of a signed integer, and it's also well within the range of an unsigned integer. So there's no difference as far as using one or the other. Quick way to move to a specific line, if I want to load, there are two ways of doing it. I can either type :10, that'll move me to the 10th line, or you can actually type move to line 10. I can do that by typing :10 and then hitting enter. Or I can just simply type 10 in uppercase G, and that will also move me to line 10. So two ways to do that. You can actually do it, not a lot of people take advantage of it. I take advantage of it now and again. Let me find, where's my Boolean function? Let me introduce a bug here. Let me forget the semicolon on line 22. Oops. So I see the error. It says it's on line 22. I can say vim Boolean function, and then I can actually say +22 right there on the command line, and it'll jump me right to line 22. So that's a nice little shortcut. Stop that. Let me look at that in a minute. How do you insert something at the end of the line without going to the line below? Right. So that's the difference between that is I is insert before character on cursor, and A is append after character on cursor. So if this is my line, Then if I should probably use A, B, C, D, E, F, G. So if I'm at the very end of the line, if I type an I, it's going to insert before the letter G. If I type an A, it's going to append after the letter G. Yeah, absolutely. That's very useful. So let's say A, move cursor to end of line and append. So just to show that, A, B, C, D, E, F, G. If I'm anywhere on the line, if I type in uppercase A, there I am. And the same goes for, what do you think that does? All right, on assignment 10, how would I dumb down my lines of code? I've already got my first shape drawn out for the second row. Couldn't I just start putting it in a loop already? Yes. The thing with the hex assignment is your pattern the patterns are usually draw, move to next position. Right? That's what's happening. So when you draw a hex, you have that in a loop, and then you move to the next position, and then if you put both of those in a loop, then you end up with a row. So how it would look is you'd have something like loop, draw hex, move to next position, so let me see, what does this loop do? Draws a column. And then you can take this whole thing and move to next column, I guess. So then this, so that this loop here is going to give us a column. After I've drawn a column, if I move to the next column, then I can put that in a loop. So note that my pattern exists. If I look at my pattern up on where I've described it on lines 1, 2, and 3, the pattern is draw and move to the next position. The stuff that I have highlighted is now the draw. That's the draw, and then 10 is moved to the next position, so I can put that whole thing in a loop, right? And then I can draw multiple columns. So that's the kind of Russian doll that you have going at the innermost level. You kind of have a little loop to draw a line and turn, and you get your hex, and then that's your drawing, and you move to the next hex position, and then that whole thing goes in a loop, and then you've got a column. That whole thing goes in a loop. Now you've got multiple columns. It's a little bit more complex given the way the hexes work. I guess you need to draw a column down. What I think I typically do is draw a column down, draw a column up, and then that thing goes in a loop, and you end up with 12, and then you have that odd 13th one that you have to do it manually. So, I don't know if that helps. All right. See how quickly, see if we can do this in under 5 minutes. Okay, initialization, counter equals 0. While counter is less than times. Cout, high. That's one loop. Do. Initialization, counter equals 0. I'll put a line in here. Cout, high. What did I screw up here? Change of state, changing times, or changing counter, counter plus plus, or I like plus plus counter better. 19. 16 yank, put. For loop. For, counter equals 0. Counter is less than times, plus plus counter. And then we're going to do line 24. That's those 3 loops. Alright, it's always the initialization, the check, and the change. The second one was this one. Print a countdown from 10 to 1. Alright. I'm going to reuse my variables. We'll say counter equals 10. While counter is greater than 0. Cout counter. Counter minus minus. There's that one. Do while counter is greater than 0. The initialization, counter equals 10. The change, minus minus counter, whatever else we're doing, which is line 36. We'll yank that, we'll put it. And then the for, counter equals 10. Counter is greater than 0. Counter minus minus counter. Cout 42 yank, put, and then I forgot the liftoff message. Cout liftoff, liftoff, liftoff. And then the last one was for here, put that there. Cout, ask the user for a name, don't stop until they type Barney. The initialization, string name, we're going to need a new variable here. So the initialization is name equals quote quote. It's a little bit gratuitous. In the case of, I made a statement before that when I create a variable, we don't know what's inside of it. Where did I create a variable? Line 11. When you create counter, memory is set aside for counter, but the language doesn't then scrub that memory clean. Whatever random stuff was in the bytes used by counter is still there. So a common assumption is to assume that counter is 0 at this point, and it isn't. So you always need to be sure and initialize it. String is a different beast. I may have said that string is not built into the language in the same sense that int, float, double, char, those are. And as just an aside, Vim knows this. You'll note that Vim does things like int, let me go down here, int, float, char, double, all these things are being highlighted. Those are kind of built into the DNA of the language. String is actually something that a programmer wrote at some point. And they wrote it such that when you create a brand new string, it will make sure it's empty. So line 54 is a little bit gratuitous on my part, but for the sake of the exercise, I initialize while name does not equal Barney. Cout name please. cn name. That's that. The do while is going to be similar. Do, I have to initialize. So at this point, name will be equal to Barney, so I definitely need to initialize it back at this point. I'll borrow 55 yank, put, add a semicolon, and then finally the for loop for the initialization, the change of state, or the check, as long as name does not equal Barney, and then the change, which is, that's where I'm actually changing it. And then in my loop, I just have to do this one. I think that's all of them. All right. It's on line 24. Do this way, undeclared identifier, line 10. By golly, it's right. So, int times. All right, there we go. Twice. Guess we need to go up and see. So I said do it 2 times. 1, 2, 1, 2, 1, 2. Print a countdown from 10 to 1. And then I'm here asking for a name. Betty. Barney. That's the first loop. Blah, Barney, and now the third loop, I'll just say it right away, and we're out. There we go. That'll be in the notes. So now I can delete that. I can get to the little trash can. How do we make the computer choose a random number between 0 and 2? Rand between 0 and 2.cpp. You have to include ctime to make sure we seed the random number generator, and the rand function and srand are in C standard library. Srand time null pointer. I know I need to update the write-up. I had null and uppercase letters. This is the old C style way of doing it. The preferred way in C++ is actually to specify it that way. Then what did I want to do? Cout a random number %. If I want it between 0 and 2, those are the remainders if I divide any number by 3. And there we go. And I'm sure if I did this long enough, we'd get to one more time. There we go. That's done. All right, I think we eliminated the questions, unless you got any out there. Okay. Let me start to talk a little bit about multiple files. I won't finish, but that's okay. All right. So to say it charitably, I've written a program on the left pane there. There's obviously no valid code in there, but what I wanted to do is demystify this include statement. We always see those at the top of a file, and there are people who go through this entire program, or even computer science programs throughout the country where they're teaching C or C++, and they think that that's a thing in the language, that the include statements always have to be at the very top. No, that's just kind of by convenience convention. But you can put a #include statement wherever you want. So the next question is, let me see if this is going to work. I may have to. There we go. All right. So I've run G++. I'm running the compiler. I put in a couple options there. The -E it means that only run what's called the preprocessor and then stop. Don't do anything else. The preprocessor's sole purpose is to look for, I'll call them directives, look for directives that begin with a £sign. If it doesn't begin with a £sign, then the preprocessor totally ignores it and spits it back out. Right? So the preprocessor gobbles up rime.cpp. It sees line 1. Line 1 doesn't begin with a £sign, so it just ignores it and it spits it back out. And that you're seeing in the bottom right-hand corner where it did spit it back out. It did hit line 2, however, and went, aha, there's something for me to do. And that is to literally, not figuratively, literally find a file out there called rime.h and simply put a copy of it right there. And that's what it did. In my upper right-hand corner, rime.h contains the second line of the rime. And that's what it does. It just sticks that line there. Now, if rime.h consisted of a bunch of lines, then it would it includes a copy of the entire file. All right, so we can see there's the entire file being included. And then, of course, coming back to here, I could put stuff after it. If I put stuff after it, that is fine as well. Let me clear the screen. That's all the preprocessor does, is it ignores anything and spits back out anything that doesn't begin with a £sign. If it does begin with a £sign, then it goes, aha, if there's something you want me to do. Yes?
Why does it have 2 lines between there? Have a little line.
Why is there an empty line there? I think it's just an artifact of the preprocessor. The reason it's not an issue is because this is upstream of C++. This is exactly the same for C, by the way. Both C and C++ don't care about spaces, tabs, new lines, right? We've had that discussion before where I've taken an entire program and shoved it onto a single line and it still works just fine. So yeah, I think it's an artifact of encountering the include statement, but it has no practical effect on the compiling downstream that occurs. Okay. So what happens is after the preprocessor is done doing its thing, it's all of this stuff that gets processed by the C++ compiler. Not this stuff that you see on the left-hand side. It's the stuff on the bottom right-hand side that the compiler sees. Now, if I tried compiling it, of course, it would fail miserably. I guess we can try that. Let me get rid of these options. Again, the -E option is what's saying run that preprocessor and then stop doing work. If I remove those options, then it is going to go on to the compiler. So note that the compiler is very unhappy about that. But there is that distinction. All right. So that's the very, yeah.
So
Oh, absolutely. Let's actually do that just really quick. Let's see. Will this work? Ooh, that's a good question. I think this will work. Let me check. Oh, I have to move it actually, don't I? So if I move rhyme.h to my parent directory, this is a good question. I don't know if this is going to work. Oops. Hang on. It did work. Yes. So there's just to say it, the pound include statements we've been seeing have had the angle braces, whereas I just used double quotes. They're 99% exactly the same thing. There's only one difference. Let me start with the angle braces. When it has angle braces, you're telling the preprocessor, please look for this file, and there actually is a file out there called iostream, in a predefined set of directories. Okay? And there are 3, 4, 5 different places where it looks for them. The double quotes is exactly the same way, except it says, first, look for that file in your current directory, and if it isn't in your current directory, then look in those predefined locations. So actually, you could use double quotes with iostream. What it would do is it would look for that file in your current location, it wouldn't find it, and then it would go ahead and look in those predefined locations. Okay, so that's why I used double quotes for rhyme, was because it wouldn't find it otherwise. And we'll continue this kind of discussion next time. At this point, we will go ahead and break, and we'll see you in lab today and tomorrow.